So I was in the middle of making the last video and my phone decided, or Apple decided, that my storage was full and I needed to try again. So let's hope that all the things I deleted will allow me to continue this video. All right, here we are. So we were on number 10, and it was the graph of a particle moving along a number line, and they asked you to determine when was it moving right, when was it moving left, and when was it at a standstill. And so that was at the end of the last video. Increasing positive slope, that means it was moving to the right. Zero slope, the particle was standing still. And negative slope, the particle is moving to the left. Okay, so the velocity is negative. So velocity is negative, that's okay, but speed is never negative. Speed is never negative. You're going 4 miles an hour in reverse, your velocity is negative, but not your speed. So we have that the velocity is the absolute value, start over. Speed is the absolute value of the velocity. So what really matters is when we're moving left, the speed at that point in time from 2 to 3, the speed is 4 centimeters per second. From 5 to 6, the velocity is -2. Therefore, the particle is moving left and its speed is 2 centimeters per second. Okay, so now we're gonna move on to number 20, and you're gonna need your calculator for this problem. So let me zoom in here a little bit. Okay, so we've been given that the position of, a particle, exciting stuff. It's a position of a particle. Maybe we should talk about how it's Phoebe's position at any given time. Okay, if you had me last year for Algebra 2 Honors, we'd like to talk about Phoebe. Anyway, I digress. So this is the equation they give you for the position. And the first thing they want to know is the instantaneous velocity at a point in time t. So velocity is the derivative of the position. Velocity is the derivative of the position. So using the power rule, the 3 becomes a coefficient, so you get -3. Decrease the exponent by 1, you get squared. Bring the 2 down in front, multiply by 7, you get 14, and then decrease the exponent by 1. And then this is t to the first, 1 down in front, t to the 0 is 1, and then the derivative of a constant is 0. So there is the equation for the instantaneous velocity. The next thing they want to know is the acceleration. So acceleration is the derivative of the velocity, which is the derivative of the position. So this is where those higher order derivatives come in that we talked about in section 3.3. So we have acceleration, derivative of the velocity, which is the second order derivative of the position. And again, using the chain rule, let me try again. Using the power rule, the 2 comes in front, multiply by -3, you get -6. Decrease the exponent by 1, you get to the first power. The derivative of 14t is 14. And of course, the derivative of a constant is 0. So the next part, C, says, when is the particle at rest? The particle is at rest. Actually, if you go to the problem that we just did in number 10, the particle is at rest, not moving, when the slope is the 0, when the velocity is 0. So here we go. It's at rest when the velocity is 0, and velocity is -3t squared plus 14t minus 14. So go ahead and push pause and do the quadratic formula. And we end up with time being 1.451-ish and 3.215. Round to the nearest tenth, the nearest hundredth, that's fine. But do the quadratic formula. It's a real world problem. So leaving your answer as, the square root of 13 doesn't make any sense. We're going to use decimals. So then the next part says to describe the motion of the particle. Okay, so calculator. So we're going to use these two values, 1.451 and 3.215. But what you need to do is we need to plug in the negative t cubed plus 7t squared minus 14t plus 8. This is where I'm at from the previous problem, whatever number it was. Turn off your stat plot. I would not delete the equations that you have in there, just turn them off. And then I'm gonna turn on, the equation was negative x cubed plus 7x squared minus 14x plus 8. And the third equation I'll get to in the next example. Okay, so when I graph it, that doesn't help me. That doesn't help me at all. So I'm going to do I always go back to Zoom 6 for Zoom Standard. And let's see how that helps us. Okay, that's pretty decent. I think I'm going to maybe change my window a little bit because really what I care about is what's happening here with the x-intercepts. And by the way, you know those x-intercepts. You already found those. Those x-intercepts were 1.451. Oh, sorry, that's not the x-intercepts. I lied. The points that I really care about are here, where the tangent is 0 when it's parallel to the x-axis. So let me zoom in first. Let me go back and zoom in. So I'm gonna do from like -2 to maybe, let's just say 6. There we go, that's better. Okay, all right. So what's happening here is we know that at 1.451, that is this low point here. And what's happening is until you get to 1.451, that value of x, the slope is negative. So what that means is the particle is moving left. The slope is negative, the particle is moving left. And then from when x is 1.41, whatever it was, and 3.2, whatever it was, between those 2 points, my slope of my tangent lines are all positive. Therefore, the particle is moving right. And then from 3.2, whatever, 3.15, blah, blah, all the way down, the tangent slopes are all negative. So therefore, the particle is moving left. All right, there's Titus and Portia trying to protect me from the neighbors. Okay. So Titus hates, well, he doesn't hate the neighbors, but he's not a particularly big fan of the neighbors. So they're doing something he doesn't like. I'm sure you could hear him. And now we're trying to coerce him inside. Okay. So now we're going to look at number 28. And these problems are on tomorrow night's homework, but I just want to get through the lesson today with you, and that way it can all be done, and hopefully this video doesn't die halfway through. Number 28 talks about marginal revenue. So this is how derivatives are applied to real life. If I increase my production, am I going to make more money? And if I increase production, do I increase cost? At what point does the consumer decide, you know what, I'll pay $10 for this item, but I'm not paying $15 for this item. So that's a big part of the business model is, how much should I make? How much should I charge? And I essentially always, you want to maximize your revenue and you want to minimize your cost. And that's just true for all business, no matter what it is you're buying or selling. Here we go, revenue. R of x is equal to blah, blah. It's in the problem. Okay, so they ask you to draw the graph, which we're gonna do last. It says to find the marginal revenue when X decks are sold. What are we selling here? Desks. We're selling desks. Okay, so what I need to do is to find the marginal revenue. So that's the topic of the problem. This is the revenue, R of x, but the marginal revenue is the derivative of the revenue. The marginal revenue is the derivative of the revenue. Okay, so what I did was, or what we're going to do, I'm going to distribute the 2,000 Okay, so the derivative of 2,000 is 0, so we're going to get rid of that. But be careful you don't drop the negative. So this is negative quotient rule. The denominator, x plus 1, times the derivative of the numerator, 0, isn't that nice, minus the numerator times the derivative of the denominator, which is 1, all over the denominator squared. So this ends up being 2,000 over x plus 1 squared. I'll move my hand in just a minute here. So there is your marginal revenue. So now it's a bunch of plug and chug. They want to estimate the increase in revenue that will result from increasing sales from 5 desks a week to 6 desks a week. So I'm going to start with 5 desks. I'm going to increase to 6 desks. And I'm kind of out of room here, so I'm just going to do it off to the side. So the revenue for 5 desks is going to be 2,000 divided by 36, $55.56. He went out the back door. Sorry. Titus is very persistent. We locked him in the house with his dog door, but he learns how to go out the back door. It's never a dull moment in my house. Okay, so now I'm going to do the graphing part last. Okay. So I'm going to turn off, oh, you can't see that. So I turned off the second equations, and now I'm going to turn on this equation. So like I said before, I always just do a zoom 6 to kind of take me back to where I'm at. I can't even see anything. Oh, you probably can't see, but it's pink. Like I have a pink straight line, which is what I would imagine you have as well. Not going to help me. So I'm going to do a zoom fit. And this is not the right graph. I don't think this is the right graph. 2,001 minus 1. Oh. Sorry, I'm sorry. Let's do a zoom fit again. And your teacher is not very smart. Your teacher has the wrong equation plugged in. I should do 2,000 over x plus 1 squared. Sorry. 2,000 divided by the quantity x plus 1 squared. I hope this works. Okay, for some reason my graph is wrong and I don't know what's going on, but the graph should look something like, I had it right earlier, something's wrong with my grid. The graph essentially looks something like this. Here's what happens. Eventually, your revenue, which is your y-axis, eventually your revenue is going to taper off. Eventually, there's going to be a certain point where it doesn't matter how many desks you sell, the revenue is going to plateau. So I can't figure out what I did wrong on my calculator there, but I know that this is what the graph is essentially supposed to look like, and it only makes sense when the number of desks is positive, right? You're not going to sell a negative number of desks. That would definitely be a poor business model. Alrighty, so this will take you through all of section 3-4. So it'll be for tonight's assignment and part of tomorrow's assignment as well.